All right, hey you guys, we are back in representing transformations in a plane, talking about rotations. This is page 15. All right, so rotation is basically when you take an object and you turn it either clockwise or counterclockwise. You can rotate it about a certain point. Maybe if you have a triangle, you can rotate it about point A or point B or point C. You can also rotate it about the origin. So rotations is just basically a turn, you guys. All right, so I'm going to get into rotations, my GeoGebra. See what we got here. Oh, okay. So we got triangle ABC, and it looks like it's being rotated about point P. So it looks like this is going to come around in a, what's that, counterclockwise motion. So let's see what's going on. All right, so it says use the slider to rotate triangle ABC about point P. Hey, there you go. Through different angles of rotation, and that's an alpha, which is a letter of the Greek alphabet. And since Euclid was the father of geometry pretty much, and he is Greek, we're going to use a lot of Greek letters here. As you move the slider, you will see the image A prime, B prime, C prime triangle. Move on the screen. At what angles of rotation does A prime, B prime, C prime coincide? Okay, so I'm looking for it to coincide with DEF. So here's my slider. I'm going to rotate it. You see triangle ABC moves. And as soon as it leaves, it becomes A prime, B prime, C prime. All right, so I had it land on DEF. It looks like it's going to be a 45-degree angle. So I'm going to put 45 in the box. All right, now the GHI. All right, so move it till it lands on GHI. Looks like it's 115. And JKL. Slide it on around. All right, so 210 degrees. Yeah, I think that's all I had to do. Yeah, all right, cool. So I'm going to submit. Hey, look at me go. Whoop, whoop. All right, question 2. Find the distance from each vertex on the pre-image triangle ABC to the center of rotation P. Enter the values in the table and do the same for the vertex on the other ones. All right, so I'm looking for the distance from A to P, and then B to P, and C to P. You get the idea. E to P, F to P. All right, so I'm going to slide this on back. The easiest way to do distance is to draw a segment because it'll give you the distance over here in your your left side chart. So I'm going to go to the third icon and select segment. I'm going to draw a segment from A to P. And come over here. It looks like it is 2.24. Now here's the nice thing about this. These are all rotations, right? So if I rotate A around, that's going to be the same thing as D to P, G to P, and also J to P. So all those are going to be the same. So D to P, G to P, and J to P. Because A prime lands on all of those. D, G, and J. D, G, and J. All right, so now I've got to find B to P. So I'm going to draw another segment. B to P. Oh, I got to select segment. So it came off of it when I hit that. All right, B to P. All right, so let's see, where am I looking? All right, so it's going to be 5. And again, because these are rotations, once I rotate around, B becomes B prime. It lands on E. B lands on H, right there. And it looks like B is going to land on K, right there. So E, H, and K will all be the exact same. So E will be 5, H will be 5, and K will be 5. All right, now I got to do C to P. So move this back around. Got to select segment, C to P, and I'm looking 4.47. And of course, we know by now they're all going to be 4.47. Now the reason why they're, again, all the same is because in a rotation, the distances don't change. You're taking the exact same figure and you're rotating it around a point. So the distances aren't going to change themselves. They're just going to rotate. All right, got that done. Question 3. What can you conclude from your observations in question 2? Well, the distances remain the same in a rotation. Each point pre-image, same distance. Look at that. Same distance. Distance is not affected by the angle of rotation. All right, question 4. Point P is presently located at the origin. Move P and observe what the rotated image change, or how the rotated image change. Be sure that neither the image nor the pre-image overlap. Remember, pre-image is the original, image is the new. Record the distances of the vertices of the pre-image. C to P. Okay, so I got to move P. So let me undo all this. Okay, so I got to move P. So let me come over here and select move. That's the first icon. I guess I'll just move it over to 1. How's that? Okay, so I moved it over to 1. Now what do I got to do? I got to find the distance from A to P. All right, so let me get my segment. Maybe I shouldn't have deleted it in the first place. A to P. All right, so 1.14 as it rotates. Hits D, G, and J. Yeah, so D, G, and J will all be 1.14. D, G, and J. Okay, now I gotta find B to P. Select my segment, B to P. That's 4.47. So as it rotates, B lands on E, H, and K. So E, H, and K will all be 4.47. Again, distance doesn't change when a figure rotates. All right, last one, C to P. All right, so I'm going to draw a segment from C to P. And 3.61, so they're all going to be 3.61. Oops. Now listen, you may have put your P somewhere differently than I did, so your answers are going to be different than mine. I put my P just kind of over on the x-axis at 1. If you put your P anywhere else, then your distances are not going to be the same as mine. However, the top 4, the middle 4, and the bottom 4 will all be the same no matter where you put your P. So you may not have the same numbers as me, but those rows should be the same no matter what. All right, so here we go, sample answer. I'm not sure where this one, okay, so they put their P at 0, -1, and I put mine at 1, 0, so their answers are different than mine, but you can see all that top row are the same, the middle row are the same, and the bottom row are the same. So depending on where you put your P. All right, question 5. All right, so let's see. How can you conclude, or what can you conclude about your observations in question 4? What happened as you move P, the center of rotation about the coordinate plane? All right, so our distances definitely changed when P moved. The distances changed. All right, what happened as you move P? How can you extend your, okay. However, the distances changed. However, how can I say that? How about this? No matter where you move the center of rotation, P, the distance is not affected. Okay. This is not affected. Okay, cool. Here we go. Self-eval. 5, baby. I'm that good. All right. So that is slide 15 on rotations. And yes, we're going to get more into rotations and reflections and translations later. This is kind of an overview of what we're going to get into. All right. I'll see you in a bit.